Alright, this is chapter 4, linear motion, accelerating, graphing, free fall, how fast. Okay, set it up in Cornell note style. That should be your title. Remember topics. Go here, information goes here. Keep that in mind as we work through this. Okay, just a quick review of graph of motions. Again, this should be a topic. Graphs of motion. Draw the graph, please. In a distance versus time graph, when you have a parabola, when you have this curved graph, this represents a change in velocity. So again, this is constant velocity when you have a distance over time. This is change in velocity. So if you have a parabolic relationship, this is considered change in velocity. Which means acceleration. Alright, the slope in general represents free fall. So free fall is acceleration, and we're going to get there. So slope is variable. So if the slope is variable, sorry, this is not just speed, it's an increase in speed. Okay. Graphs of motion. Again, you already have this header. This time we have velocity versus time. Please note the difference between these labels. This time when you have this, the slope represents acceleration. We have a slope of velocity versus time. So again, if this is your v versus t, and you have a constant, that's a terrible line, but if it's constant, this is a constant velocity. Okay. If it's increasing, this is considered linear or directly proportional, which means if one goes up, the other goes up. So as velocity increases, time increases. Or as I guess you should flip-flop since time is the independent variable. As time increases, the velocity increases. This is a directly proportional relationship. When the slope is constant, it's an acceleration. All right, when the slope is all wiggly, so some of you guys had on a quiz, and on the lab, something like this, and like that. That's just a change in, you have a constant velocity, then you go to a faster constant velocity, okay? All right, so instantaneous acceleration. So trying to figure out an acceleration at any given point is you have to figure out, so tangent, so if we're trying, so notice they must be slowing down a little bit. You have a line, a tangent line. The slope of that line that's tangent to the slope, that's the acceleration. So whatever this is the acceleration. Remember, slope is rise over run. If it's positive, we're accelerating. This is negative acceleration, I guess, in physics terms. Or in everyday terms, deceleration. And if you didn't notice this, this is velocity. That's what the y-axis is. Again, when it's flat, it's constant. Okay? It's a constant velocity, no acceleration. Okay? Again, this gives you an idea of tangent of an accelerating car. You figure out, so if they have a curved slope, this is indicating that they're speeding up, and their acceleration decreases. So this would be like entering a highway. You get the green light, you hit the gas, you speed up, and then you start slowing down your acceleration because you're hitting close to that 60 mile per hour mark. And now we're at 60 miles per hour. You've reached it, so you're good to go. So that's what this represents. Okay, now free fall. Here's the definition. Free fall is when an object falls under the influence of gravity alone. So the only thing acting on it is gravity. No air resistance, nothing. So what we know is every second of fall, an object increases their speed at 10 meters per second. So, which means acceleration, or free fall, is 10 meters per second. So at this point, they're going 10 meters per second. At second 2, they're going 20 meters per second. Second 3, they're going 30 meters per second. And 40 meters per second. So on and so forth. This would even be farther down. It would be way off the page, way down there. And it would be going 50 meters per second. Okay, notice it's really hard. Like, you would have to have a really tall cliff in order for this thing to free fall for more than 6 or 7 seconds. Keep that in mind. Important. Theoretically, near the surface of the Earth, gravity is actually 9.8 meters per second. When we calculate the velocity of an object, we take gravity times time, okay? For class purposes, to make your life easier, we're going to use 10 meters per second. Okay, don't write this. So, by the way, if you haven't titled your next topic free fall, make sure you include it. Don't write this. This is obvious, especially if you just drew this picture. So if you drew that picture, that just is demonstrated in graph form here. All right, so again, elapsed time is 10 meters per second times t. So if I fell for 30 seconds, I would be going 300 meters per second. So that's crazy. Again, this is repetitive. Free fall is acceleration. It's change in speed over time. I don't think you need to write this because we already did acceleration in notes. Okay? Here are the different versions of how we rewrite it. This is also already in your notes. We've also put it in the equation section. The only thing to realize is when we're accelerating, the velocity is like the instantaneous velocity. What is it at that exact moment? Because every second it's changing. Okay, this is important. I told you guys that we're now pretty much in algebra class. It is physics. We're using algebra to explain how the world works. So you're going to have a lot of letters. This new letter is G, obviously for gravity. Acceleration due to gravity is represented by the letter G. The cool thing is, you know the number for G. If you memorize G equals 10 meters per second squared, you're solid for any time you see the letter G. You just should know. Like, automatically G is 10 meters per second. In English, just so that way you have a reference point, it's 32 feet per second squared. So every second they fall 32 feet. All right, that's crazy. But you should know that is 9.8 just for like test questions, but math questions on a test, I'll ask you to use 10. To figure out their speed, again, this is velocity equals gravity times time. We already wrote that. Okay, so what if I throw a ball up? So if I throw a ball up into the air at 30 meters per second, at 0 seconds, it's going 30 meters per second. At 1 second, it's going 20 meters per second because it decreased in speed by 10 meters per second. Why? It's repelling gravity. Same thing here, minus 10 meters per second. Minus 10 meters per second. Which means when it hits its peak, its velocity should be 0. It's stopping, and now it's changing direction. So now it's going to increase by 10. 10 meters plus 10 plus 10 each time. So at the top, its instantaneous speed is 0. Okay, rises, and as it rises, you should write that. The top is velocity is 0. You should write that. As it falls, it speeds up at a rate of g. Equal elevations have equal speed, but opposite velocity. So this is going to be key to note when you do your concept development. Equal elevations have equal speed. So notice, let me change my pen color here. This, 20 meters per second. 10 meters per second. Okay, 30 meters per second. Each time, they should have the same speed, but the opposite velocity. So 30 meters per second going up is positive, and then when it starts going back down, so if you throw it up, you are telling us that it's the positive direction is up, which means down is the negative direction. Okay, so homework tonight, concept development, pages 13, 15, and 16. Skip 14 for now. Well, you don't have an equation to go with it.